Okay, hello everybody. This next section, Unit 2 on statistics, is an introduction to one variable statistics. One of the first things that you see in Unit 2, Activity 2 is something that's brand new for students, this summation notation. And it throws a bit of a curveball to a few students here. It's not a tough concept, but for some of you guys, it's going to be brand new. And certainly some of you have been out of math and haven't done math for a little bit of time here. So here's summation notation, okay? So basically this Greek letter, sigma it's called, is summation notation. What it means is you're just adding together sort of a string of terms here, starting at the indexes that are on the summation here. So that's where it's k equals 1 to n. So there'd be n terms. They would start at the first term, then the second term, then the third term, all the way up to the nth term here. And that's represented when you add the terms together. That's represented with a summation notation. Mathematicians and scientists are notoriously lazy, and they like to abbreviate things as much as they can with formulas, and in this case, summation. So that's how it's explained, and certainly it's things we can work through. Okay, so a lot of really good examples. I want to make sure that everybody's reading these examples. If you are in the lesson, Unit 2, Activity 2 lesson, the examples start right off the bat here. Walks you through it, explains the different parts of the sigma expression, and it walks you through how to evaluate them. Usually when the lower limit and the upper limit, or the indexes, are relatively small, the easiest way you can evaluate a summation notation is just to expand it out. Okay, be careful with your operations. Okay, make sure you're talking about the first term here. Let me just see if I can. Okay, so this is the first term. Okay, the second term, the third term, and the fourth term here, and that's okay. So this is the first term, this is the second term, this is the third term, and this is the fourth term. I use a lot of brackets, especially when the expression is large. I use a lot of brackets, and you make sure that there's a plus sign in between them. Then it just becomes a question of just doing the math and evaluating properly here. Okay, I'm online here live, so it's a little glitchy. I just want to make sure that. We go through this process. Okay, so there's the question we're on here. Okay, and it just works out to be a number. Now trust your math. Okay, make sure you do it properly and follow the order of operations. Use lots of parentheses, but trust your math. You guys are in 4U math, so you should be pretty good with this, but just be careful and try not to make mistakes, because sometimes these questions can be quite large and tedious, I said earlier, but certainly, okay, it's a question we just have to be cognizant of and careful with. Okay, so here's the expansion of this expression. Okay, there's another one. Okay, now they can be expressed in a lot of different ways. Okay, the variable is irrelevant. You'll often see K's and L's and M's and N's for whatever reason. The indexes can start at different values. In this next example, it starts at -1, okay, and goes to 7. Okay, so it has to go through in order for -1, 0, okay, 1, 2, 3, 4, 5, 6, all the way up to 7. Sometimes the indices can be very large, and it helps to have some formulas here that we're going to, and works with some properties here. There's no way I'd evaluate and want to write the string of sine of 3 pi plus the sine of 4 pi plus the sine of 5 pi all the way up to 100, okay, as an upper bound of 100, okay, in that many terms. Okay, so there are a series of properties that help us evaluate these summation notations. Okay, if I can identify a constant, I can pull that out and just multiply it by. If I can identify the sum of two terms, okay, I can find the summation of each of the terms and then add them together. Same thing with differences. Okay, and then there's also some common formulas here. If I recognize that I just got the addition of plain natural numbers, I can use that formula to get the sum, okay, rather than go to my calculator and work on that. If I recognize it's a sequence of squared numbers or a sequence of cubed numbers, I can use the appropriate formula here. Okay, and then the assignment is just going to walk us through some examples here, following some of our examples that are in the lesson here. I'd encourage you guys to carefully go through this, okay, see the different types of questions you can have, okay, and work on the following examples and take the answers. I did include a summation notation video from YouTube, and I'm going to add this one in the assignment page. So in the assignment page, let's take a look at a couple of questions here. Okay, this is a submitted assignment, so I'm not going to do all of these, but I certainly want to make sure that you have an idea how to properly get started on these. And this can challenge some students, okay, but this is, like I said, this is the first part of the course where we're doing some math, and it's a submitted assignment. So expect to be thinking a little bit. This is just not going to be a sort of a repeat of examples and questions you did in the lesson, okay, and you will be expected to think a little bit here. It's a 4U math class. I want to make sure that we sort of keep that accountability up with this type of class. Okay, so let's take a look at the first 7 questions here. Simply just expand these out and evaluate them. Okay, so just at a glance, 3 to 7, that's easy to evaluate. 0 to 3, 1 to 10, that even might be, but I could probably use one of my rules here if I was careful. I certainly could use one of my rules for 6, or I could for number 4, or I could evaluate it because it's only 6 terms. 5, same thing. 6 with the cosine. I want you to expand that out and look for patterns, okay? And that applies to 7 as well too. If I start to expand that out, I'm going to see some patterns here, okay? So in 7, okay, when I expand this out, I'm just going to grab my sheet here. Okay, so I've got a summation, okay, that goes up to 150. It starts at 25. Okay, and the summation is 1 over I plus 4. Oh, sorry. Minus 1 over I plus 5. Okay, so I start at 25, so let I equals 25. So my summation is going to be 1 over 25 plus 4. Subtract 1 over 25 plus 5. And I keep doing this. Okay, so now I'm at 26. So I'm going to have 1 over 26 plus 4 minus 1 over 26 plus 5. And this is going to continue for a long time, all the way up to 150. Okay, let's do 49. Let's do the 149th term. Okay, so that'll be 1 over 149 plus 4 minus 1 over 149 plus 5, and then my last term, 1 over 150 plus 4 minus 1 over 150 plus 5. Now, I'm not going to do this for you, as I said, but I want to make sure, okay, that you do this a little bit intuitively, and a lot of math at this level is going to be just using what you know, okay, and trying to look for patterns, trying to develop your answer, okay, and seeing if you can sort of get to the final solution in a sort of an intuitive or a really quick way here. So on that note, let's continue with the solution here. So I've got 1 over 29 minus 1 over 30 plus 1 over 30 minus 1 over 31. Okay. All the way up to 1 over, be careful, 149 plus 4 is 153, okay, minus 1 over 154, okay, and then I've got my last term is 1 over 154 minus 1 over 155. Okay, let me shrink this down a little bit so we can see it all on our screen. This is what I've got, and I've left out a whole pile of stuff in here, okay? But when I write it like this, do I see something or do I see a pattern? Okay, it's just a series of addition and subtraction expressions, so I can drop my square brackets. Now we should start to see something. Oh, I said I wanted to drop that square bracket. So now I've got 1 over 153 minus 1 over 154 to leave it right here. Okay, and maybe point out that's 0. This is 0. Sorry, this is 0. This one's 0. Okay. These next ones would be 0. This one would be 0. This is a whole lot of zeros in this firm expression. It really just leaves me with. Okay. And you guys can get the final answer here by subtracting these fractions. I want your answer in a final fraction. Okay, so that's 7. I maybe did a little bit too much with 7 here. Okay, let's keep rolling along here. Let's take a look at the rest of this. Okay, 10, look for patterns. Okay, 8, 9, and 10. Rate this as a summation, so look for patterns here. And you want to talk about terms here. Okay, so in a question like 8, I talked about the first term. Like this is my first. Let's go back to my. Okay, so in question 8, okay, I've got 1 over 2. Okay, plus 2 over 3. Okay, plus 3 over 4. All the way up to. I want to replace this string of numbers, okay, with a summation. Okay. Now to help you, this is your first term. This is your second term. Okay, your third term. And it looks like 1, 2, 3. It looks like I go all the way up to 50th term. So right away I've established my indices. If I like my lower bound, okay, my lower limit, all the way up to my upper limit. And it looks like I could have I in my numerator, because that just cycles through 1, 2, 3, all the way up to 50. And it looks like my denominator is also related to my term, but it's 1 greater than my term. So if my first term is 1 over 2, okay, I can represent that with y representing my term, but I could have an I plus 1 in here. And it looks like that pattern follows all the way. The denominator is 1 integer higher than the numerator in each case. And that's how we would write that. Okay, so 10 is a bit of a challenge. You have a oscillating sign. It goes from positive to negative to positive to negative, and that might challenge some students, but I'm going to leave that with you guys. 11, 12, and 13. 11 and 12, just combine those. Okay, don't evaluate. Okay, 11 and 12 is just asking you to write them as a single sum. You don't have to evaluate them. In that case, look at the indices, okay, the lower limit and the higher limit for each of these, and see if you can combine them as one. Okay, and then 13 and 14 and 15 are word problems, okay, that sort of look at how you can represent that as a sum, okay, and using sigma. And they're pretty interesting. I don't think they're too bad. By the time you get to them, you will have a pretty good idea of how to work with sigma notation and summations, and just understand that they represent, okay, use summation. When it says use summation notation or find totals, it represents, okay, that sigma notation. Okay, so good luck with this, and try and work through it the best you can. Thanks, bye.